Wassa Distance Education Center and PLAR Science. So we're into week 5. So this week is May 13th to May 17th. And as you know, the weekend coming up is the long weekend. So that means that next week, on week 6, we don't start until Tuesday, May 21st. And another announcement that I have is just for this week, so for this week only, PLAR Math will be on Tuesday, the 14th, and Wednesday, the 15th, which means that PLAR Science will run on Thursday, May 16th. So today for PLAR Science and Thursday for PLAR Science, PLAR Math will be on Tuesday and Wednesday. So just for this week only, same time from 4 to 5. You can still apply for IL courses. You can contact your local DEC, Candace or Michelle. You can go to our electronic WASA sign up. So just go to that link. If you're not sure what it is, you can go on Facebook or you can call the office and we can give you an online application form. Students can also sign up for term 3, and term 3 is from June 24th to August 23rd, 2024. So we have a set of courses: English, math, science, history, and co-op. So lots of courses there for the summer. We have 5 teachers who will be marking the courses. So make sure if you're interested in taking summer courses or term 3 that you sign up. And again, you can contact your DEC, Candace or Michelle. I believe there is an edit already for the summer courses, so we will give you the updated version of that. Term 2B draws, term 2B draws. WASA will have 2 student draws, so one for students who earned a credit, so that's one of the draws, and then the second draw will be one for students who submit work. So make sure that you're submitting your work to your teacher if you want to be entered into the draw. And of course, students working on more than one course will have their names entered for each subject that they submit work for. If you have any questions, make sure you're contacting your teacher. So we have our office number and hours, 1-800-667-3703. That's toll free. My extension is 2204. You can fax us as well. We have a toll-free number for that. We have email, Facebook. So I have a work Facebook. It's under J. Mercer Wassa. You can also contact me there through Messenger. And you may also call me at home. Once you're ready to submit your work, you can have your DEC fax it for you. They can also email it to studentwork@nnec.on.ca. Make sure it is CC'd to the teacher that's marking the work. So if it's for me, for PLAR Science, History, or Geography, make sure that it's CC'd to jmercer@nnec.on.ca. You can use your Notes app to scan email. You could also send a picture through Messenger. Okay, and the good thing about that is when you send a picture or if you scan it, you have a copy of your work so it doesn't get lost. I can print it off from my end, or you could drop it off at our WASA office. There is an outdoor mailbox on the side entrance, or you can just drop it off at reception. So remember, if you're dropping off your original, make sure that you photocopy it, or you can ask us to scan it for you so that you have a copy of your original work. Remember, you can submit your work as you complete them and contact your teacher if you need help. Okay, evaluation, how you will get your equivalent credit for this course. Some students have a culminating activity, which means that you have completed all key questions 1 to 80 of lessons 1 to 5, and then I have sent to you the culminating activity. Once you have that, you need to complete it and then send it back. Okay, that is the only way you will get your equivalent credit. You need to do this assessment. It's an open book test. So it's either your DEC gave it to you or I gave it to you, so make sure you complete it, because otherwise, even though you did all 5 lessons, you will not get the equivalent credit for it. If you need extra support, so if you don't call me but you want to watch the classes, you can go to YouTube. You can watch the classes that's under the playlist. This is also for PLAR Science, Math, History, Geography, and English. So in this case for PLAR Science, you can see that I am uploading the science classes in PLAR Science 2B. Sorry, that should say 2B. It's an old picture. I will update that. So when you go there, it will show you all 10 classes that we have already. Sorry, 8 classes. Okay, so for this week, after this week, there will be 10 classes in there. If you don't want to watch it there, you can also request a USB of classes. And remember, the classes can be viewed on your laptop, also on your television, Xbox, or PlayStation once you insert it in the USB port. To open the class, notice that each recording will show you the subject, so PLAR Science. It will give you the lesson number, so lesson 1, and then it will give you the key questions that's in that video. So for that one, it's key questions 6 to 12. So if you're having any problems or you would like more information for those key questions, then you should watch that particular video. And again, if you're not sure, contact me. So if you're having any problems with the PLAR Science, History, or Geography, and then you can contact Bonnie for the PLAR Math and English. Okay, for this afternoon, we are now looking at the teacher comments or marks to student. We have completed lesson 1 and lesson 2. From our last class in lesson 3, we did as far as key question. Let me just double check here. We did as far as key question 45. Nope, we did as far as key question 44. So we will start with key question 45 today. Okay, so we have 4 key questions completed so far in lesson 3. Again, if you're not sure, each cover page of the lessons will give you all the contact info that you need, whether it's the WASA studio number, the office number, the fax number, email, our YouTube links, and the Google Classroom codes, whether you're using the NNEC Schools account or if you're using your personal account. In lesson 3, you will see a sheet that says lesson 3. It will give you the topics, it will give you the key question number, and the total mark. So this is a good page for reference. That way you can use it as a checklist. So if you look at chemistry, key question 41, you can check to make sure that, hey, I did that one, or 3 states of matter. So keep checking the work that you have completed. If you have any questions regarding any of the topics, then if you put a circle on it, for example, formula for starch, key question 50. If you're not sure how to do that, put a circle on it. That way you can contact me and ask me about it. For this afternoon's class, we will start off with page 17, what are elements? Page 18, the periodic table. Page 22, what are compounds and molecules? And page 25, what is a chemical formula? And we'll also look at page 8, which shows us the different types of molecules. Okay, learning goals. Keep this in mind. We want to understand how matter is classified into pure substances and mixtures. I will explain the difference between a chemical reaction and a physical change. So, quick review, we looked at matter, and matter can either be solid, liquid, or gas. And then it's divided into pure substances, and once we have the pure substances, it can also be subdivided into elements and compounds. Now, elements mean that they can contain a single type of atom. So, for example, iron is an element, and it only contains iron atoms, nothing else. Whereas compounds, these are a substance that consists of two or more different types of atoms, and they're bonded together. If you want to say stuck together, okay, or chemically bonded, that's what compounds are. Compounds is different from elements because it is made of elements in a specific ratio that is always the same. It has a chemical formula. So for example, the element iron, okay, the symbol for it is Fe. That means iron. But the chemical formula for, say for example, water is H2O, because it has a specific ratio. So H2 meaning it has 2 parts hydrogen, so it contains 2, and it has 1 part oxygen. Okay, and it's fixed. And the only way that it can be separated, it can only be separated by chemical means, not physically. Okay, the other half of the classification of matter. So we had pure substances. The other one is mixtures. And then that's subdivided into heterogeneous mixtures and homogeneous mixtures. So the first one, homogeneous or homogeneous, however you want to say it, remember that means the same, and heterogeneous means different. So homogeneous means you cannot see the different parts or phases of the mixture. That means that in this kind of mixture you can't distinguish the components. So even though you have a milkshake, you can't see, let's say there's water in it, there's milk, there's strawberry syrup to make it taste like strawberry. There's obviously sugar so that it's sweet. Okay, and so on. But you can't see all these parts. Same thing with coffee. So this coffee might have sugar, it has milk, it has coffee granules, and so on. But it appears to be just one thing. That's why it's called homogeneous or homogeneous, because it's the same throughout. The opposite of it is heterogeneous, which means different. It means that you can see the different parts or phases of the mixture easily. A good example is a toss salad. So you can pick out the things in there that you don't like. So let's say if you don't like the onions that are in there, maybe the olives, tomatoes. So if you don't like it in there, you can just literally and physically pick those out. Fruit salad, same thing. So that one has bananas, oranges, kiwi, watermelon. You can pick them out, you can see them, and you can pick them out of the bowl if you don't like certain fruit. Okay, so that was a quick review for matter and its classification. The next term is molecule. So molecule is the smallest indivisible particle of a type of substance called a compound. A molecule is formed when two or more atoms combine to form a new particle. So it is very hard to separate the atoms of a molecule. Remember I said H2O means 2 parts hydrogen, 1 part oxygen. So you have hydrogen and oxygen, they're bonded together and it forms a water molecule. Okay, there are different types of molecules. Molecules that are made up of 2 of the same atoms. So if you have 2 parts hydrogen, 2 parts nitrogen, 2 parts oxygen, these are called diatomic molecules. So basically 2 atoms together, but they're made of the same atom. There's also examples that we have here include molecules such as oxygen, which is O2, or nitrogen N2. So here are elements that exist as diatomic molecules: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So a compound consists of 2 or more elements chemically bonded. So this is the key thing here, is it's the fixed ratio. So when you have 2 different atoms that join together in a particular way, they are called molecules. So an example of this, as I mentioned, was a water molecule. So it's H2O. That means you have 2 parts hydrogen, 1 part oxygen. CO2 is the carbon dioxide. So you have 1 part carbon, 2 parts oxygen. These are called molecular compounds. Okay, they're 2 different atoms, but they're joined together. Ionic compounds, these are made up of 2 different atoms, but they transfer their electrons between the atoms. So an example of an ionic compound would be table salt. And the formula for that is NaCl. So examples of ionic compounds in everyday life: sodium chloride, commonly known as table salt, or sodium bicarbonate, commonly known as baking soda, sodium hydroxide, okay, you probably know this as lye or drain cleaner. Sodium hypochlorite is also known as bleach. Magnesium sulfate, okay, is also known as Epsom salt. So these are your everyday life ionic compounds. Okay, so now we have this all together. Remember, you should review this. This will be in your culminating. Again, it's an open book test, but if you have this in front of you, it will help you with your work. So now we have matter. So all the stuff that's around us, we know that it can be either solid, liquid, or gas. And then we further divide it into either pure substances or mixtures. So pure substances can be divided to elements and compounds, and then mixtures can either be heterogeneous mixtures or homogeneous mixtures. So turning to page 11, look at the key. So the key is the white circle means is an atom of one element, and the black circle is an atom of a different element. The diagram shows you some of the types of matter. So the first picture shows element. So remember, the white circle means atom of one element. The picture is showing two white circles, and they're stuck together, or you can say bonded. These are what's known as diatomic molecules because they're made up of atoms of the same element. So it could be gold, silver, iron, etc. The second picture shows you a molecular compound because all particles are made up of the same number and type of atoms. So you have one black, one white, and they're stuck together. So these two are also bonded. Examples are water, salt, propane, caffeine, and so on. But they're two different atoms. One's black, one's white. The third one shows you a mixture. And we know it's a mixture because you have two white circles and two black circles, and two white circles and two black circles. It's a mixture of two types of diatomic molecules. An example would be carbon monoxide. And then finally, the fourth picture shows you a mixture of two different types of particles. So an example would be pop, sandwich, rocks, where you have, for example, rocks are made up of mixtures of different rocks. Okay, next. And that one is on page 12. Properties of matter. So physical properties are the characteristics that can be observed or seen using our senses. So I guess it's not just seen, but if you use your senses, you have you can see, taste, touch, feel, hear, so on. Taste, hearing, smell. So these senses are observing physical properties of these substances. So a physical property is a characteristic or description of a substance that may help identify it. So physical property could be a color. You might say, is it black? Is it white? Is it colorless? Red, greenish, yellow, and so on. Odor. So if you're, can you smell it? Taste, is it sweet, sour, salty, bitter? Texture is just the feel of a substance to your fingers. Is it fine, smooth, gritty, coarse? Okay, so those are different explanations. So if you look at the first one on the bottom of the screen, this would probably be you would be using your sight because you can see the different colors. This one would be, I'd say, odor. You can probably smell toast. This looks like it's burnt, so you might smell it. And you might not want to taste it because you might not like burnt toast. Apple, there's a bite taken there already, so taste. And then this one, different materials, would be touch. be bumpy, soft, furry, fuzzy, rough, and scratchy. Okay, so these are all physical properties. So if you look at them, the physical property of it is the characteristic or description of these substances that can help you identify them. Other ways, luster is the ability of an object to reflect light. So is it shiny or dull? Clarity is the ability of an object to transmit light. So is it transparent, meaning is it clear? Is it translucent? So is it cloudy or opaque, not allowing light through? Physical state, well, is it a solid, a liquid, or a gas? Melting and boiling points, which are the temperatures at which substances can change state. And then hardness, is it a measure of the resistance of a solid to being scratched or dented? So pages 12 to 13 are physical properties. There's more. Page 14. Malleability is the measure of the ability of substance to be hammered into a sheet or bent in shape. Copper is an example of that. So you can bend it with pliers. Brittleness, the ability of an object to break apart or shatter easily. Okay, so that could be glass. Ductility is the ability of a substance to be stretched out into wires. So it could be material that can be pulled out or drawn into a wire. So a couple examples here. That looks like copper. Okay, and the other one looks like it's a plastic hose. Okay, and then solubility is the ability of substance to dissolve in a solvent, such as water. Sugar has a high solubility in water, so if you put sugar in your coffee, it will dissolve. Oil has a low solubility in water, so if you put oil in water, you'll see it will float. Viscosity is a measure of how easily a liquid will flow. So the thicker the liquid, the more viscous it is. Honey, molasses, these are examples of viscous liquids. Density describes how much mass, which is the quantity of matter, an object contains in a given volume. So for example, you can have 1 kilogram of steel and 1 kilogram of feathers. Okay, and that would, what do you think would happen there? What was the density of it? So substance with greater densities have more mass packed into the equivalent volume than substances with lower densities. So you can see how much feathers you have to get for it to be 1 kilogram as opposed to a 1 kilogram of steel. So it'll take up more space, even though they weigh the same. So that means that lead has a greater density. Okay, you only need less of it, but with feathers, you need a whole lot of it to weigh the same. Okay, let's try one of our key questions. Let's do key question 45. So a glass of orange juice is a type of matter. What type of matter is orange juice? So that's the first part of the question. So what type of matter is orange juice? So explain your choice. Remember to write your answer in complete sentences and use proper scientific terminology that you learned in the note about matter. So first of all, what type of matter is orange juice? Well, we know that orange juice is a liquid matter. Okay, we know it's liquid. What else can we say about orange juice? We know it's a liquid matter. We can go further and say if it doesn't have pulp, it is a homogeneous mixture because it appears that there's only one phase. Even though even though it has water, orange juice, sugar, might even have coloring, it only looks like it's orange juice. Okay, so you can't see or separate the different parts. Okay, so we got key question 45 completed. Okay, next up, what are elements? So as of 2023, there are 118 known different kinds of atoms that have been identified. This means that everything we know, or every kind of matter, must be made up of one or more of these 118 kinds of atoms. Just like if you thought about the letters in the alphabet, there are 26 of them, but we have millions and billions of words, and they're made up of those letters. So if there are only 118 kinds of atoms, then there must be 118 different kinds of elements. There's one element for each kind of atoms, which means that the atoms of any one element are almost exactly alike. 90 elements occur naturally in nature. 4 or 8 elements that occur in nature as a result of radioactive decay or of heavier materials. So the total natural of elements, depends on who you're asking, is 94 or 98. You know the names of some of these elements: gold, copper, iron, oxygen. Maybe you also know iodine. Most elements are found in the solid state. Some are found as gases, but only 2 elements, mercury and bromine, are found as liquids at room temperature. So you might remember this. This is probably don't use these now. Some places still do. This is a thermometer, and inside it there's mercury in there. Okay, and the mercury, okay, is a liquid at room temperature. So if you put this tip, okay, under your tongue, so the higher the temperature, you'll notice that the mercury will move. Okay, and then you can tell what your temperature is. Okay, this one is bromine. Okay, and that's also an element that is found as a liquid at room temperature. So there are certain percentages of various elements in the human body. Oxygen makes up 61%, carbon makes 23%, hydrogen 10, 2.6 for nitrogen, calcium, notice it's at the top of our head, 1.4, phosphorus 1.1, and then the others are at 1.0%. So atoms and the periodic table. In 1913, British scientist Henry Moseley discovered that he could measure the number of electrons in an atom using X-rays. So each element was then assigned an atomic number based on the number of electrons in one atom of that element. So for example, oxygen, based on that, the atomic number is 8. The atomic mass is 15.999. The element symbol is O, and the element name is oxygen. So in the following slides, you can find the periodic table of the elements. The symbols for the elements are the same all over the world. So it doesn't matter whether you're in Australia or Japan or France. If you're looking at the periodic table of elements, the symbol will be the same. So it might not be called oxygen, but the symbol is O, and it means that it's oxygen in that language. So it makes no difference what country you are in or what language is spoken there. The language of chemistry is the same all over the world. Okay, the names of the elements are written in symbol form. So symbols are signs that stand for something else. Here are some symbols that you may know. For example, the dollar sign, the percent sign, the number sign, or the pound sign. So what does each one stand for? Well, the rules for writing elements as symbols are, so when you're writing the element, the symbol always begins with a capital letter. So think of it just like when you're writing your first name. You always start with a capital letter, so an uppercase. So if it's helium, and the symbol for helium is capital H, lowercase e, because if there is a second letter, it is a lowercase letter. Just like your name, when you're writing your name, if your name is Bob, okay, the first letter is B, second letter is O. Okay, it's not capitalized, only the first letter. No period is used at the end of the symbol unless it comes at the end of the sentence. And like I said, the symbols for the elements are the same all over the world. That way there is no confusion. So you can see that. So symbol, shorthand abbreviation for the element name. It says C, capital C for carbon. The element name usually is from a Greek or Latin word for the element or a substance containing the element. So elements are represented by symbols, and no two elements have the same symbol. Usually one or two letters. Here are some examples. Oxygen, the symbol is O. Carbon, symbol is C. So remember, if it's just one, it's capitalized. So capital letter. Hydrogen, H. Sulfur is S. Those with two, lithium, Li, so the first letter is capital and the second letter is lowercase. Helium, capital H, lowercase e. Argon, capital A, lowercase r. And silicon, capital S, lowercase I. Elements on the periodic table are divided into two main groups. They are either metals and nonmetals. There are more metals than nonmetals, and the metals are on the left side of the table. The nonmetals are on the right side. A heavy step-like line divides the two groups. So I'll show you here what it looks like. You don't have to memorize these. So as you look over it, you will learn a number of things about elements. First of all, you likely recognize many of them. So if you just take a look at it, maybe there's some there that you already know. You've likely heard of hydrogen, sodium, calcium, carbon, neon, potassium, platinum, and tin. It's arranged in order of increasing atomic number based on the periodic law. So elements having similar chemical properties and electronic structures appear in vertical columns. Okay, that means it's up and down. So when you're looking at the periodic table of elements, Si is silicon. The atomic number is on the left-hand corner. It's 14. The atomic weight is 28.9. The symbol is there, so capital S, lowercase I. And then you have the name of it, silicon. If it's in black, that means it's a solid. If it's in blue, that means it's liquid. If it's red, it's gas. If it's white, it means it's synthetically prepared. Okay, that means it's not natural. So the next set of pictures I'm showing you is the periodic table of elements, but it's in pictures. If you look at lithium, okay, which is Li, you can find lithium, that element, in batteries. An element, sodium, you can find that element in table salt. Potassium is an element that you could find in fruits and vegetables. Let's see here. Scandium, you can find an element in bicycles. Titanium, you would find it in objects like aerospace. Chromium, you can find that in stainless steel cutlery. Nickel, you could find that element in coins. Copper, you'll find in electric wires. Zinc can be found in brass instruments. Silver and gold you can find in jewelry. Mercury, like I said, thermometers. Osmium in pen points. Tungsten in lamp filaments. Let's continue here. There's more. Okay, indium in liquid crystal or displays in LCDs. Lead could be if you do some exercises, you might find those in the weights. Iodine can be found in disinfectants, and so on. So how do elements get their names? Well, the symbols for most elements are taken from their names in other languages. I said that earlier, mostly Latin and Greek. For example, the Latin name for iron is ferrum, so the symbol for iron is Fe. Lead symbol is capital P, lowercase b, and the language of origin is Latin for plumbum. Gold is capital A, lowercase u is a Latin word for orium. Lithium, capital L, lowercase I, language of origin is Greek for lithos. Several elements are named after places or after famous scientists. For example, Am for americium and Es for einsteinium. So californium is an element. Symbol is capital C, lowercase f. It's named for California. Curium, capital C, lowercase m for Marie Curie, who was a French scientist. Fermium, capital F, lowercase m is the symbol. And it's named after Enrico Fermi, who was an Italian physicist. Okay, let's try key questions 46 to 49. That should sum up our class. So key question 46, how many elements exist in nature? Now, this is not a trick question, but you do have to read it carefully. It says in nature, not how many elements exist, but specifically how many elements exist in nature. Key question 47, in your opinion, so what do you think, why is it so important to have only one set of chemical symbols in the world? So remember, I said that there are many languages spoken, different languages in the world depending on where you are, but there's only one set of chemical symbols. So if you travel anywhere and you look at the periodic table, the symbol for iron will always be capital F lowercase e. Okay, so why do you think that there's only one set? What might be the possible reason? Key question 48, give the names of the elements with the following symbols. So we could do these together. You can look at your book. So A is capital F, lowercase e. I just did that one. So that is the name. That element is iron. Capital C is carbon. Capital O is oxygen. Oops, spell that properly. Capital C, lowercase a is carbon. And then capital C, lowercase l. Okay, do you remember what that one is? Okay, that one is chlorine. Now we're going to do the exact opposite. This time we have the name of the element and we just have to put that into symbols. So symbol for gold is capital A, lowercase u. Hydrogen, capital H. Lead is capital P, lowercase b. Helium, capital H, lowercase e. And uranium is capital U. Okay, so for next class, which will be on Thursday, what I want you to do is start reading what are compounds and molecules. So compounds and molecules start on page 22. You can also try the key questions, support questions on page 14. It shows you in your notes, copy the chart below and give 2 to 3 points for each component in the flow chart. So for example, it shows you the classification of matter. And then number 2 says copy the table below into your notebook. Choose one of the following to fill in the classification column of the chart. So it'll give you items like sugar, tea, baking soda, and then it'll ask you for the classification, whether it's a solution, a pure substance, a mixture, or is it a compound. Okay, so don't forget that for this week, PLAR Math will run back to back on Tuesday and Wednesday, same time, 4 to 5 p.m. And then PLAR Science will be 4 to 5 on Thursday. Okay, so I won't be talking to you until Thursday. All right, that's it for this afternoon. Thank you for joining me. Big wedge.